and then give us Jordan, who is our first speaker. And he's the co-founder of Motherduck, a startup building a serverless analytics platform based on DuckDB. Last year, Jordan mentioned that this name is a placeholder, but it looks like the name grew on him after all. And Jordan comes with an impressive track record as a product leader, engineering leader, and book author, and he's very eager to share his knowledge with us, and we are so lucky to have him here. Please, everyone, welcome Jordan Tigani.
Thank you very much. Good morning, everybody. Thanks for being here. It's very exciting for me to get to come out here to this conference. I spoke virtually at this conference. I think it was last year or the year before, and since then I left my old job, started a new company, and there's actually a Hungarian connection because the person who invited me to this conference was actually the person who kind of verified or convinced me that some of the ideas that I had been thinking about and been working on actually had some legs. So that was I have a hard time with the Hungarian names, but I think it was Balázs Mate. So anyway, I owe him a big debt of gratitude. So who am I? So I got my start in my career kind of working at Microsoft and Microsoft Research. Worked at a couple of startups. The second startup I worked at, actually I started working with large data sets. And this was super exciting to me, so I went to Google because Google was the place where you go to understand big data. I helped start Google BigQuery. I grew that, worked on that for over a decade. Ended up kind of leading engineering and leading product. So that was sort of a very exciting time. Then I left and went to single store, so to get to see how the real world works when you're not necessarily at Google. And over those last couple jobs, I sort of started realizing some things about the world that made me interested in starting something new. But there was sort of an underlying theme for the last sort of decade, which is I've been working on cloud data analytics and helping people understand their data. So I think if you really want to do something interesting, you want to look at figure out what is going to happen. You want to build for the future. You shouldn't just be looking at, what's true, what is something that everybody understands about the world now, or what's the conventional wisdom, because you want to figure out, what is something that's actually true, but nobody has realized that, or few people actually realize that. Actually talking to Balázs, he mentioned that he goes to these conferences, and everybody talks about sort of this giant, large-scale architectures, the Netflix architecture, and he's like, well, what am I going to do? Run a single-node Spark instance? It's like they get excited, but not everybody has some of these, giant data sets, and so that's sort of how I started coming up with this idea that big data is dead. So just a quick show of hands, like how many people routinely operate over petabytes of data? Nobody. All right. How about tens of terabytes? All right. We have a few hands. Less than a terabyte. All right. A lot of people less than a terabyte. So it turns out that there's a bunch of reasons why a lot of the things that we've developed for handling big data are less relevant or less important than they used to be. The first one is just most people don't actually have that much data. You think about a SaaS business. You have thousands of customers, business to business, thousands of customers is actually doing pretty well. You have 1,000 entries for each of those customers. That's 1 million rows. That's not a whole lot of data. So kind of from my time working at BigQuery, I looked at the amount of data that our customers had. We had tons and tons and tons of tiny customers, like people using less than a gigabyte, less than a few gigabytes worth of data. And I was talking to somebody about this, and he said, It's like, wait, why would you use BigQuery if it wasn't for you weren't using big data? And it was like, there must be something else going on here. But even pretty large enterprises didn't have huge amounts of data. In fact, I was talking to somebody from just the other night at the speaker dinner who works at a very large data observability company, tens of billions of dollars in valuations, and he was saying, look, yeah, we don't. Our customer data is pretty huge because the sum of all the data of all our customers is really large. But in terms of the actual business data that we use to sort of do predictions and analysis, it's actually pretty small. And then sometimes people do have a lot of data, but a lot of the time that it just sits there. So I also kind of looked at the how much data was processed versus how old that data was. And the last day is something like 50% of all queries. The last 7 days is something like 90%. There's sort of a bump when you look at like kind of the weekly and then 2 weeks and then monthly. But for the most part, like most of the when you have large data sets, they often were created over long periods of time, and most people don't actually look at the stuff that happened a long time ago. And if you think about it, it doesn't actually make sense to query that data in detail unless you're sort of like, okay, when was the last time that X happened? But if you're just looking at dashboards or something that you're updating frequently, in general, the questions you want to ask of that old data you've already asked before, and to like search through that row by row is doesn't make sense and is expensive. The other one is that just people query less data than you'd think you would. Like modern data systems can query only a small sliver of data, rather than having to query the whole thing. And in generally, people look at you look up a single user, you look up a single day, a single customer per query. And so most of the time, you're actually not dealing with large amounts of data. And these sort of the 90 percentile and the 99 percentile, depending on who you ask, those are in different places. But generally, the percentage of queries that operate over less than a gigabyte are very, very high. And you just think, okay, if you're building systems and you're only using data that's less than a gigabyte, or your queries are over less than a gigabyte, how would you design them differently? So the next thing that this next sort of realization is that laptops are incredibly powerful. It used to be that laptops were sort of synonymous with underpowered. It's like, I could run that on a laptop, meaning like it's really sort of a trivial amount of computation. And sort of when I was working on BigQuery, laptops were reasonably underpowered. I think this even sort of undersells the difference, because it used to be, they were kind of flimsy, but now that Mac M2s have super fast memory, super fast SSDs, and are much larger. So the amount of work you can do on a laptop is much larger. So if you think about like, okay, well, all this stuff that we do in the cloud, that's all costing me money. But I've already paid for this laptop. Why should I run that in the cloud if I can run it somewhere else? I think even when you're sort of actively using your these hefty laptops, they pretty much are idle. And so like if I run a query against Snowflake or BigQuery, my essentially supercomputer on my desk is sitting there mostly idle while I'm paying for some expensive cloud resources. The CEO of Fivetran did a blog post a couple months ago that I thought was super interesting, and he was talking about DuckDB, and I'll talk more about DuckDB in a bit, but he was comparing DuckDB versus running on his laptop. He had a 2-year-old M1 laptop, and compared that against a popular cloud data warehouse. And this chart is a little bit hard to read, but basically the lower the line is, the the faster it is. And essentially for most data scales, the laptop was faster than the cloud data warehouse. And I think this is, before DuckDB performance improvements in the last version. This was, running on an older laptop. I think these numbers would be actually considerably better now. So that's what one of our slogan is. My laptop is faster than your data warehouse. So the next big thing is that servers are really big now. So a lot of the data infrastructure was all built assuming that you had to run scaling out across vast numbers of machines, because those machines themselves were relatively small, they were brittle, and they were expensive. Like if you just think about all of these sort of scale out systems, starting with MapReduce, they are designed to operate over large numbers of machines, because the actual machines are pretty small. But if you look at the actual machines that are running in AWS, the EC2 machines, or in any whatever your favorite cloud is, like the actual machine that your virtual machine is running on is a super beefy machine. So maybe not the 25 terabyte instances, but at least 256 gigabytes, often 128 cores. So even just sort of the basic machines are quite powerful. And if you think about the number of data workloads that you have that will fit on a single machine, and if you think about just how much work it is to build systems and maintain systems and keep them up to date and worry about consistency and distributed algorithms, et cetera, like you can build much more simple systems if you can run on a single machine. And so I think the last decade has been sort of really all about scaling out, having massive numbers of machines. But scale up is actually really entirely viable these days. It's like, yeah, why not just run on a single node? And I think AI, generative AI, is the big buzzword these days. And I think one of the tricky parts of a lot of these algorithms is these algorithms don't scale out. And a lot of AI ML workloads, they work well on a big machine. They don't work if you have 1,000 small machines. So it's just yet another reason why you may want to scale your workload up rather than across lots of machines. All right, who likes ducks? Just about everybody likes ducks. There's a couple people over here that I think they like ducks, but they're too cool to admit it. But actually, everybody also likes DuckDB. And this is something that we started realizing. I encountered DuckDB when I was at SingleStore. It was this kind of embedded database out of nowhere that could do a bunch of things that we couldn't do in SingleStore, and often giving us a run for the money in terms of performance. And SingleStore, which used to be called MemSQL, like the whole idea of it is it's fast, and the fact that this brand new database could at least be comparable in a lot of cases was pretty surprising. And also DuckDB, because it could run anywhere, it could shrink down to very small sizes. It's like there were a bunch of use cases where we're like, hey, there's something going on here. One of my favorite Twitter people who loves to do benchmarks and various things, and he's I think one of the first things I heard about this was and he's like, yeah, the first time I ran a query on a billion rows, and I did it on my laptop. So A, you can do some pretty powerful stuff on a laptop, and B, this was actually pretty fast using DuckDB. So what is DuckDB? So DuckDB is a lightweight, in-process analytics database. So if you think about the comparison to SQLite. So SQLite is sort of the transactional version that SQLite is everywhere. It's in your phone. It's in it runs. I think it's one of the most popular pieces of software in the world. because it's so simple and robust. But SQLite is not really designed for analytics. And if you try to use it to run sort of analytic-style queries, understanding the whole data set rather than doing point updates and lookups, then you're going to have a much harder time. Just so the DuckDB star history is sort of has been trending significantly up. DB engines is the kind of the ranking of databases that database nerds love to sort of follow, and like every month reload the site and see like what has changed over time. And the DuckDB curve looks very, very, very strong. And actually one of our investors, they said if you look at the curve from Snowflake and the curve for DuckDB, they actually look almost identical. They're just kind of off by about 6 years. So what do we mean by embedded database? So an embedded database runs in your application. It's just a library. So typical database, you have the application has some sort of driver. It's a JDBC driver. It's something that can kind of call out to your database. Then over the network, you have your database sitting on a server somewhere, crunches the data, and returns you the results. In an embedded database, that all happens in process inside your application. DuckDB does have drivers, and it does have a bunch of like JDBC, et cetera, connectivity, but I think one of the key things is that it just sort of runs inside your application. So as a developer, it's really, really easy to use because all you have to do is link in the library, and then you can run your unit tests against it. And it also has all the kind of the familiar trappings that you may also be used to. So kind of put these things together. Big data is dead. Your laptop is super powerful. Your servers. Okay, if you need to run in the cloud, servers are enormous. You can scale up, and then DuckDB is this awesome piece of software. And so these are the 4 basic ideas that I use to say, hey, there may be something new that we can build, and this was sort of the basis of Motherduck. And so Motherduck is when we're thinking about it, it's just DuckDB in the cloud. So we're taking DuckDB. And we can run it in the cloud, but we can also run it locally, and I'll talk a bit more about that. But so just comparing DuckDB to Motherduck, DuckDB is an embedded database. Motherduck is the sort of the cloud platform that is based on it. I just also want to mention if you're not a fan of ducks, you probably you're getting sick of ducks by now. There will be more ducks in this presentation. Okay, so if big data is dead, then what actually is the important thing? All of these systems that have been built with the driving factor being data size. Okay, how do you make this scale? How do you make this scale up to 10x the size of data? And that's really been driving the architecture. And I think one of the really important things is you want to make data easy. So it's like actual ease of use is going to be incredibly important. And I think that's really the secret sauce, the reason that people love DuckDB, is because they just figured out how to make it easy. And I love this analogy, which is that in general, database companies and data infrastructure companies, they're selling you a burger, but they put all of their energy into the patty. It's like, how do we make this the best patty? How do we make these queries run faster? How do we make these optimizations better? But really, like the part that they care about starts at when they get the query, and it ends when their query is done. But that's actually only a part of what actually needs to happen in order to provide a good experience. Like how do I install it? How do I connect it? How do I get my data in? How do I get my data out? How do I get the results out? And if you look at just some of the things that sort of DuckDB has, for example, if you're using Python, you can use DuckDB to query directly against your Python data frame. You don't have to like move data out anywhere. You don't have to move data back in. You just select star from my data frame, group by whatever, and that just works. They also have been sort of pioneering with a new data connectivity format called ADBC, which uses Arrow, but JDBC and ODBC are the typical ways that people connect to databases. JDBC for Java, ODBC for everything else, and they're actually super old and super crufty, and they're designed for row stores and not column stores. So if you've got analytics data, it's so much more effective to use column stores. The data gets marshaled around if you're using ODBC or JDBC, and this is just a new way of doing that using Arrow, and much more modern. A couple things that were just recently announced is like if you're using R. So maybe people here aren't data scientists. Any data scientists in the room? A handful, okay. Your data scientists who use R, dplyr is really common. DuckDB can be a drop-in replacement for dplyr. That's just much, much faster and easier. And there's also a drop-in Spark replacement. So if you find yourself getting excited about some architecture and using Spark, but it's small enough, what you're doing is small enough to fit on one node, and I think most workloads are small enough to fit on one node, then you can basically just migrate over to using everything using DuckDB. You don't have to change any code. It just all uses DuckDB under the covers. As I mentioned, it's just a library. You just link it in. Super, super simple. Unit tests can run in microseconds. And then can run anywhere. It can run in the browser. So this is one of the things that actually is pretty exciting to me, which is you can run a full-blown database in the browser by using WASM, like WebAssembly. To the best of my knowledge, this is sort of the first time you could run a full-blown analytics engine in the browser. And it's only 100 megs, so it's not like you have to download a whole lot of massive binaries. You can run this, or that it's going to sort of take over your machine. It's zero dependencies. So that was one of the things that the founders of DuckDB, they really believed in, which was you have to be able to install it without having any writes on your machine, because actually they didn't have any writes on the machine that they were using, and so we can't install anything. So that meant you can't we can't rely on anybody else's code. So they re-implemented a bunch of stuff, which sounds a bit goofy these days. But in doing so, that's why they can run it in such a small footprint. Like SQLite, it's just a single file, so so you can email around your database, and you can also easily query data lakes. So with Motherduck, we wanted to extend that idea and just sort of make cloud analytics easy. So if DuckDB was making local analytics easy, we want to make cloud analytics easy. And one of the things that the way we've built it is we've built it as an extension to DuckDB that automatically loads if the database name starts with the Motherduck prefix. And so if you run DuckDB foo.db, you're running a local file. But let's say if I want to run in the cloud, you just do DuckDB md:/foo, and then now you're running in the cloud. That's literally all you have to do to start using Motherduck. Okay, so I talked earlier about laptops being super powerful. So if laptops are super powerful and you're spending a lot of money to run stuff in the cloud, well, why not move some of that work locally? And so one of the things that we did with Motherduck is we built hybrid query execution, which will kind of let you seamlessly move work down onto your local machine. And I have some reasonably technical slides here, but I do want to just sort of go into sort of why this is interesting. So if you think about you're running a server-based query engine, you have to connect to the client somehow, and typically the way that's done is you just send the query and then you get the query results back. But instead of doing it that way, we kind of integrated deeply within the query pipeline and made it so that essentially what we're sending is the query plan, and we're only sending the part of the query plan that has to run on the server. And really what this lets us do is it lets us, if we get the query locally, we parse it locally, and then if stuff needs to run locally, we run it on your laptop or on your whatever machine you're on. But if it references data that lives in the cloud, it'll run in the cloud. And then if you're joining local against the cloud, then we'll actually kind of figure out what data needs to move up versus what data needs to move down. And I'll talk a little bit about that. So let's say we have this SQL query. You're computing the average cost per passenger, and the sample data set lives in the cloud in Motherduck. But you're joining against data that lives in a CSV file that lives just locally on my laptop. And generally, this is hard, and generally you'd have to upload the data, you'd have to do something special with the data. But here you're just running the SQL query, and then here's the adding the filters and the aggregations, et cetera. So here's what the query plan looks like, and the goal here is not to actually go through all of this and to understand it, but it's also kind of hard to display a readable query plan on a single slide. But I want to call out a couple of things. The first one is this R, so that means that runs remotely. And we see at the end, we're going to run stuff on the server, and then we're going to download the results. And then we also had data that lives locally, and so that's what this L is. And so we need to upload the data locally. And we don't upload the file. We just upload kind of the minimal amount of data that has to be done. We also do cost-based optimization. So if the local file is actually much larger than the cloud data, we'll do it the opposite. Is we'll download and then do the join locally on the local machine. But so that query just works. It's fast. It's not really noticeably slower, or it's not any slower than running it either completely remotely or completely locally. Completely locally is usually a little faster, but all right. So laptops are powerful, move work locally. Servers are enormous. How do we take advantage of these larger sizes of servers? Well, it's pretty easy. Build a scale-up system instead of a scale-out system. And so if you think about sort of building a cloud-hosted analytics system, you can simplify a lot of things when you do scale-up. If I remember, back to the BigQuery days, there were things you wanted to do in join where, in order to solve one type of query in one of the TPC benchmarks, we had to sort of implement this thing where we pushed these Bloom filters across the network, so you could do filtering on the other side. This took probably 2 engineers a year to do and to get all of the corner cases right. Whereas in a scale-up system, everything is a shared memory space. You just share a hash table, and you're done. You just share a pointer to the hash table, and you're done. And also, you ask, can you scale up? So in, I think it was 2008, Google released a paper called Dremel, and based on an internal query engine that's the one that underlies BigQuery, and they showed some benchmarks of how fast Dremel was, and at the time, this blew people away. It was oh my God, this is so fast. They ran it over 3,000 nodes, and so one of the main queries they ran, took about 20 seconds to process. What is it? Half a terabyte worth of data. At the time, also this seemed like a lot. But if you sort of look at what you could do on an AWS instance these days, you can actually exceed that performance if some of the data is either staged on SSD or is in memory. If you have to read all of that data off of S3, it's probably going to be a little slow, but there are some instances that are fast enough. And the other thing is, dramatically less cost to just do this in a scale-up system. And if you also just think of like the coordination between 3,000 nodes, the amount of like RPCs that have to go back and forth, your 3,000 nodes, the chances are like, if the uptime of each one of those is a day, basically one of those is going to be failing every few seconds, and so you have to build in all kinds of mechanisms to do retry and failover, et cetera. Scale up just so much simpler. So the architecture that we built in Motherduck is a scale-up system, running in Kubernetes, and one of the nice things that about Kubernetes is it allows us to sort of be fairly dynamic. We need to be a little bit more dynamic than Kubernetes gives you out of the box. So essentially what we do is we just run a whole bunch of DuckDB instances in separate Kubernetes containers, but give them all of them think they have full access to the machine, all of the memory, all of the CPU. And then we use kind of user mode mechanisms to sort of limit the CPU, limit the memory of all the instances, but this also allows us to scale up, scale down very, very quickly. And so, you can get effectively all of the resources on a single, large AWS instance. All right, so we're scaling up because the servers are enormous. So now DuckDB is awesome. What can we do to make DuckDB even better? So what we've done is we've built a sort of a full-fledged data warehouse on top of DuckDB. So DuckDB is an embedded database. An embedded database is not a data warehouse. It's missing a whole bunch of things. It's missing authorization. Like, it has no idea of what a user is. It's missing sort of a durable storage system. It stores things in a single file. If you have like data that you're sharing, if you have larger amounts of data, like storing everything in a single file is really not the best way to do things. So we built our own storage system. There's the scaling, caching, et cetera, all these things that you want to build in a robust data warehouse. Also, if I should mention that we're basically only 1 year into this, so some of these pieces are a little bit more rudimentary, but effectively these are going to be becoming more fully fleshed over time. The other thing that's important is, like, if you're doing data analytics, you need to be able to have it connect to the tools and the things that you're already doing. And so these are just the things that we launched with. There's actually a handful of other ones that we've added in the last couple of months. But you have to be able to get data in, and chances are you're coming from some other your application database is some other database. One of the nice things about DuckDB is it can query directly over Postgres, and so you can pull data directly out of Postgres. But 5-trend connector is coming. Airbyte connector, actually, we just launched. But there's a bunch of good, nice ways to get data in. We have a really good DBT connector, and then on the visualization side, we have a really strong partnership with Hex. If you're running in Hex, you basically can tell Hex. So Hex has these really nice cells in the notebook that run over data frames, and those are using DuckDB, and you basically can just tell Hex, okay, I want to use Motherduck for these, and then all of a sudden all of these are using Motherduck, and then you have full access to your cloud data without having to change anything else. But we also integrate with a lot of the other BI tools. Tableau, actually, we also just launched. Looker is coming very soon. So kind of put these things together, and kind of these are the insights that led us to start a company. But just sort of stepping back a second, the questions that we want to ask and just understand, is what are people analyzing, first of all? And it turns out it's not as much data as people would have thought. People tend to only query over recent data. Older data is much less frequent. And then queries that you do run actually operate over a smaller slice of data. And then what software and hardware do you actually need? Well, the hardware advances both on the laptop side and on the server side have increased dramatically, and so single machine can be much more powerful, and this lets you be software to be much less complicated. And I actually think these sort of these questions are interesting whether or not you end up using DuckDB or Motherduck. It's just sort of like, hey, I'm building a system, I'm building a data system. Maybe you could think twice about what kind of physical resources are needed to solve your problem. And then lastly, kind of what do you need to make it not just work, but make it ducking awesome? We think that we really believe at Motherduck that sort of hybrid execution is this sort of killer thing where you don't really have to know where data lives. You just can run queries. You can do better capacity planning, better query planning. And then just finally, as you kind of think about building systems, what industry trends used to make sense or made sense at the time, but no longer make sense because something underneath is changing. Perhaps the most recent phase shift is AI. Everybody these days is thinking about, well, how is generative AI and AI in general going to be changing my job, changing how I interact with data, changing how the kinds of things that I work on, the kinds of data infrastructure that you need, and so these are certainly things where I imagine that if you can have some good insights, then can help you figure out what the next big thing is, and be able to actually take advantage of it. All right, so that's all I have. Stop quacking, get querying, and let's make analytics ducking awesome. Thank you so much.
Now I know why my phone is autocorrecting things and it's writing ducking awesome. That's why. I think we have some questions. Do we have questions? Yes, we do. A lot. Ooh, I'm sorry. It's going to be a lot.
Worries.
Bring them on. All right, let's start with the most top-voted one. You guys can still send your questions. DuckDB doesn't have to deal with concurrency, permission control, etc. How can Motherduck achieve that features without performance penalty?
Permissions, user management, etc. Those are things you generally can add on the connection side rather than on the query side. And so a lot of these things you can do without a performance penalty. There's a lot of stuff that can be cached. There's a lot of stuff that you can do to make some of those things fast. Concurrency is an interesting one, and one of the things we're doing in Motherduck on the concurrency side is that we are running a separate DuckDB instance per user and per workload and per region. And so you really don't have to deal with nearly as much concurrency because if you have 100 users in your organization, they're not all hitting the same instance. They're actually hitting 100 different instances. And actually, if some of those users have multiple workloads, that may be even more instances. So yes, DuckDB is not great at concurrency. It's getting better at concurrency. I mean, that's something that is going to happen. But the nice thing about the size and shape of these DuckDB instances is they can be tiny. So you can run lots of these instances, and that's sort of one of the patterns that we've seen a lot.
All right, thank you. Can DuckDB work with 3S or HDFS as a data storage? If so, did you compare it with Apache Iceberg performances?
So yes, DuckDB can DuckDB can query Parquet files or Iceberg files that live on S3. It does so naturally. So a lot of databases are actually external queries, or they end up using a separate system. So if you're querying something that's outside the database, you have to use kind of special code, and it doesn't have a lot of the performance optimizations. The way DuckDB was written, it doesn't matter if it's native DuckDB or an external scan. You get access to all the same performance benefits. So yes, you can query on over S3 or GCS or Azure Blob Storage, and it should be very fast. The thing you can't do yet is if you have a DuckDB file, you can't query that from S3 yet, but that support is coming.
Makes sense. Can you provide some specific examples of how DuckDB helps individuals and orgs operate over data locally, especially when dealing with data of varying sizes?
Yeah, so a lot of the times, people, they want to just take a small portion of the data, or even their data size is actually pretty small, and just sort of operate over it, iterate on it very quickly. And especially, if you're doing data science, if you have a notebook, but also if you're doing a lot of types of analytics, to be able to just say, okay, I'm going to put this on my laptop, and I'm not going to have to worry about what everybody else is doing, can be super useful. Additionally, you may want to basically take a branch of the data. So there may be, and let's say you're building a data pipeline. You don't want to break what's running in prod, but you can sort of take down a version of that data. You can make some modifications to make sure whatever your pipeline is continues to work over that data, and then you can push that back to prod.
Gotcha. I love the next one. I'm a CTO on a private jet to LA meeting management about cloud data costs. Are they going to sack me if there is a duck in the room? Peak cloud 2030 is real?
Maybe they'll sack you if there's not a duck in the room. No, I do think that there's a lot in this that can dramatically reduce your cloud costs. I also think that there's some interesting security things to think through. If you're an enterprise administrator, you may not be super excited about people downloading a bunch of stuff on their laptops, and that's something that we are actively working on. And I think the way we're responding to that is that, okay, well, chances are you're going to have people that are doing this anyway. Don't you want auditability and being able to and local encryption and remote wipe and et cetera, those types of things that you wouldn't get just by default.
Couple of more questions? Yes?
Sure, yeah, of course.
Alrighty. What are the advantages and disadvantages against MySQL and MariaDB of DuckDB?
So great question. So MySQL and MariaDB are transactional databases. A lot of people use them for analytics as well. A lot of people use Postgres for analytics, and it's one of those things that works well up to a certain scale, and then you hit a pretty big wall. So I think one of the typical things that people do is they're building an application or they're just getting started with data, is they just point their BI tool at their application database, their MySQL, their Postgres, and then they realize, A, that slows down my production database. B, the schema that I want to use for analytics is different than the schema I want to use for live queries. And then C, it's just slow. There's row stores versus column stores. MySQL and transactional databases tend to be row stores, good for looking things up, good for making point updates. Column stores are much better for doing aggregations and scans and the kinds of things you want to do in analytics.
All right. Can you utilize other available laptops across the organization?
That's a super interesting idea, and I think one of the things that we're toying with, and I think it's one of the kind of the cool things with this sort of hybrid execution topology, and I have a whole separate talk track about this, which is that once you sort of have local and remote as part of like a single logical database, you can build other topologies. They could be single, local, near edge, far edge, or cache for per country, and the other thing you can do is you could also reverse it, and so you can actually send a query from the server to the clients, and they can fan out, because there's a lot of times where data is being generated in lots of different locations, and then people spend a lot of money consolidating that, and a lot of time, a lot of energy consolidating that into their data warehouse. Wouldn't it be easier if you could just run a single query that runs, where the data is being generated? We haven't necessarily thought about applying that to laptops as well, but that would be a kind of a cool idea.
Thank you. Is DuckDB competing AWS Athena? If yes, can you use Glue Catalog?
It does a lot of similar things to AWS. AWS Athena, makes it easy to query over, local data. I think that, AWS Athena is, people tend to not use it for kind of heavy analytics. They use it for kind of exploratory stuff. The pricing model is, per byte scanned. I think we can do things more efficiently. We don't support Glue Catalog. We should absolutely look into what would be necessary to support that. But it's a great idea.
All right, let's quickly run through the last 3 questions. Could you please elaborate on the concept of medium data and explain how it differs from dealing with large data sets in terms of workflow design?
Yeah, so I think medium data, because small data is something that will fit in a spreadsheet. You probably don't need any additional tools to work on that. And then sort of, and a lot of data falls in sort of the medium data, or I saw somebody call it sort of a reasonable sized data. And from a workflow perspective, if you're dealing with large amounts of data, there's all sorts of, and you're scaling out. There's all sorts of things that can go wrong, and there's all sorts of interesting consistency problems when you're dealing with this sort of, because now you have a distributed system, and you have failovers, you have retries, et cetera. Like it's a much simpler system if you're using something that does scale up. A lot of tools will kind of abstract away the differences. So if you're using Airflow, if you're using dbt. You don't necessarily have to know the differences. The only difference you might notice is sort of less configuration and better performance.
Gotcha. Last 2. How does the arrow focusing on how data is used rather than its size impact the way traditional data analytics tools are designed and used?
Yeah, I think that it's a good question, and I think that it's something that we're going to start to see differences where, just because for so long, the underlying infrastructure was designed to scale out, designed to handle large data sets, and so the next levels of tools that were built on top of that, we're sort of all making assumptions about those sort of lower level things that there may be ways to be more efficient. And I'll give an example that kind of can be enabled with Motherduck, and that's if you can run DuckDB, a full-blown analytics engine in your browser, well, how does that change BI? How does if you're building dashboards, you should be able to do slicing and dicing and drill downs at 60 frames per second. I mean, you should be able to get video game style update frequency or visualization interactivity. And that doesn't exist yet. So I think as people start to come to terms with some of these things, it's going to unleash a new way of handling your data.
All right, and the last one. Sorry, Istvan, you can approach Jordan in the break. Can you tell a little bit more about cost optimization when using local and remote together? DuckDB can get the AWS instance type, region, etc. as an input.
Yeah, so one thing, at least for how Motherduck is being built, is is anything you run, anything we can push locally, you don't pay for, and so anything you're running on your laptop is free, and there's also some interesting sort of like carbon usage or emissions cases for actually pushing stuff on your laptop. And yes, using stuff on your laptop does tend to cost electricity, but those tend to be sunk costs and not the driver of electricity. But if you're running stuff in the cloud, then DuckDB can run on an AWS instance. It also can, because in Motherduck we're running in a multi-tenant system, we can do it a lot less expensively than if you just ran your own EC2 instances. And so we can, it'll be even less expensive than trying to run it by itself in EC2.
All right, thank you very much for championing all of the questions. Thank you so much. Let's give a warm hand to Jordan.
Thank you.
And here's a small token of appreciation. Look, it's you.
Wow, thank you.
Without ducks, but hey, we can draw it later. Thank you so much.